Hello, this is the luckiest maths teacher in the world. Today we look at scales. Now, of course, scales have many different meanings. We're looking at the ones you might use in scale drawings. So you would have seen scale drawings in your life, perhaps without even knowing that you'd seen them. A map, for example, is a scale drawing. We're going to look more at these drawings in the next lesson, but today we just want to get comfortable with the scales that they use in them. So what exactly do these scales look like? Well, they're a ratio. So they might look something like this, 1 to 1,000. Now remember, a ratio compares two quantities of the same type. The scales we're talking about compare lengths. So the first number is always something about the drawing. So that number refers to the drawing or the plan, the actual scale drawing. The second number refers to real life. So what this scale actually means, because it's talking about length, is for every 1 unit in the drawing, that represents 1,000 units in real life. So if you had a map, 1 centimetre, if you measured out 1 centimetre on this map, it would represent 1,000 centimetres in real life. If you measured out 1 millimetre, that would represent 1,000 millimetres in real life. Now, you always have the drawing first. That number first always refers to the scale drawing, but you can have the larger number first. You can have something like 4 to 1. So again, the first number is drawing and the second number is referring to real life. So in this first one here, the larger number was real life. So that actually represents a reduction. That means you've taken like a big object like Australia, and you have reduced its size so it can fit on a scale drawing. If you have the larger number first, as we do in the second example, that's an enlargement. So what that means is you're actually taking something really small and your drawing is bigger than the actual object. So a ratio of 4 to 1 basically means that the drawing is 4 times as large as the real life object. So you might be drawing something really small like a bacteria or something like that. So these are the kind of scales that we're using. We need to get comfortable converting scales and converting units. So let's go ahead and do a few examples. So much of what you'll have to do involves equivalent ratios. So you might be given a question like this. You might be told you have a scale of 1 to 1,000, and you might be asked 1 millimetre inside the drawing, how many meters does that represent? So this question is basically saying, if I had a scale of 1 to 1,000 on a scale drawing, and I measured 1 millimetre on the actual drawing, how many meters would that represent in real life? Now, fortunately, this is actually quite easy because we've done a lot of converting units in our previous topic. So, of course, a scale of 1 to 1,000 means that 1 millimetre represents 1,000 millimetres. That's what a scale of 1 to 1,000 means. For every 1 millimetre you measure in the scale drawing, it represents 1,000 millimetres in real life. So all I have to do is convert 1,000 millimetres to metres. Well, that's easy. So, of course, there's centimetres between millimetres and metres. So first I'm going to convert to centimetres by dividing by 10. So 1,000 millimetres is 100 centimetres, which is, of course, 1 metre. So if I have a scale of 1 to 1,000, that means 1 millimetre on my scale drawing represents 1 metre in real life. So now we're going to go ahead and look at an example where you're given some measurements and you have to figure out the scale. So we'll go ahead and try this example. If 2 centimetres on a map represents 5 kilometres in real life, what is the scale? So this is actually just equivalent ratios. So we have 2 centimetres to 5 kilometres, and we want to make that into an equivalent ratio. Now the problem we have here is that there are different units. So what we do is we get them to the same units and then we can just get rid of the units. So I'm going to convert the kilometres, the 5 kilometres here, into centimetres. So this is the same as 2 centimetres. So 5 kilometres is obviously 5,000 metres. Now I'm going to convert the metres into centimetres. So I need to times 5,000 by another 100. So I get 500,000 centimetres. So now I've got the same units in each, so I can just get rid of the units. This is a scale of 2 to 500,000. Now, we won't do a lot of this, but very occasionally you will have to simplify a ratio. Now, remember, a ratio is just like a fraction. So 2 to 500,000 can be simplified. You do that by dividing each number by highest common factor. If you really have trouble with that, just put on your calculator 2 over 500,000. It will simplify it for you. It will tell you that that's 1 over 250,000. So this first number, this number on top is the first number in the ratio, and this is the second. So that's the same as 1 to 250,000. So if 2 centimetres on a map represents 5 kilometres in real life, the scale of that map is 1 to 250,000. Okay, now we're going to actually use this to solve some problems involving scale drawing, so please pause and copy down if you need this example. So this is the kind of question that you will have to do. So you're being told that you have a map of Canberra with a scale of 1 to 100,000. So obviously that means for every 1 unit in the map, it represents 100,000 of those units in real life. So firstly, we're going to figure out if 2 suburbs are 3 centimetres apart on this map, how far apart would they be in real life? So this is, again, just using equivalent ratios. So we know that the scale is 1 to 100,000. Now we need that to equal 3 centimetres on the map. We need to figure out how far that would represent in real life. So these two last numbers correspond to real life. The first numbers correspond to distance on a map. So all we have to do is figure out what number goes in there so this ratio and this ratio are equal. So those who are smart, have a lot of common sense, you will realize that all you need to do is times by 3. So we've times by 3 to get from this number to this number. So for it to be an equivalent ratio, we times this number by 3 also. But if that doesn't make sense, if you're really worried about this, what you can do is you can put an x for the unknown and treat these like fractions. So this here, this ratio can be written as a fraction. It doesn't matter whether you write it as 1 over 100,000 or 100,000 over 1. The second ratio can be written as a fraction. Again, you could write it as 3 over x or x over 3. It's probably easiest if x is on top. So we're going to write this as x over 3, and we want that to be equal to this fraction here. Now, because I wrote the real life quantity on top of the fraction here, I have to write the real life quantity on top of the fraction here. So now I've just got an equation. It's easy to solve. I just times each side by 3. So you can see I get the same result whichever method I used. Now the thing is that because this is 3 centimetres, x is 100,000 times 3, which is 300,000 centimetres. So what we need to do is put this in a measurement that's easier to understand. So if I divide by 100, get rid of the 2 zeros, I have it in metres. So it's 3,000 metres, and of course that's equal to 3 kilometres. So if 2 suburbs are 3 centimetres apart on a map, they are 3 kilometres apart in real life. Now to do B, we're doing the same except we're looking for the first number of the second ratio. So what I mean by that, we still have the same scale, 1 to 100,000, but this time we know that they are 13 kilometres apart in real life. So 13 kilometres is the second number, and we need to find the first. So this one's a little harder to solve just using common sense, because it's not obvious at all what I times by 100,000 to get 13 kilometres. So it might be easier in this case if we put an x here and solve for x. So again, I want x to be on top of the fraction because it's so much easier that way. So x over 13 equals 1 over 100,000. Okay, so essentially what I'm doing is I'm just dividing this 13 kilometers by 100,000 because I know that the real life distance is 100,000 times as large as the distance on a map. So that's all I'm doing. So x is going to be 1 over 100,000 times 13, or if you like 13 divided by 100,000. Okay? Now you can use your calculator for this. And of course, the answer that you get is 0.00013, but that's in kilometers. So again, I'm going to change it to a measurement so it's easier to understand. So I can times by 1,000, so move the decimal place 3 spots, and it's now in meters, and 0.13 meters I can times by 100, it's in centimeters. So, if McGregor is 13 kilometres from the city in real life on the map, that will be 13 centimetres or 130 millimetres if you like, apart on the map. I hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.